start. We are on in your books on page 71. Once again, that's 71. If you were in my class on Friday, you already have these notes. I'm going to highlight some things and I'm going to teach it to you just like I was standing in front of you, let you know what to write down, where it should go. So the first thing we're looking at is this thing here called evolution. And the first thing to remember is that what does this term evolution really mean? Okay. Um, to look at evolution, I'm going to compare it to something we've already talked about. If you look at the word geological in terms of the earth, well, the earth has changed over time. And so if I said geological evolution, I'm talking about the earth's surface and how that's changing. We know this because we looked at how Pangea, through the use of continental drift, split apart and eventually created the continents in our present day. If we're looking at the word evolution, which simply means change, we also can look at probably the most commonly used technological device today, which would be the cell phone. To tell my age a little bit, when cell phones first came out, they looked like this. Some of you don't even recognize these things. Then we went, in a couple of years, they went from having these to what they call the Nokia bricks. And then we had the Blackberries. Well, that's going back in time. But eventually, cell phones went from being really big to being really small. They went from only being able to answer the phone to being able to answer the phone and send a text. They went from that to be able to take pictures, really bad pictures, but pictures. And now we can access the internet. We have unlimited Wi-Fi. But if you're looking at this, if I were to drag this out over 2019, the iPhone changed the smartphone market, but the reality is that life is about change. All things change over time. And so that is also true for technology, but also biological evolution. So here's your first little major word here, biological. And what I want you to know is the word biological, or the prefix bio, means life. So the same way geo means earth, okay, or tech means a tool, bio means life. And so life on the planet is always changing. Matter cannot be created or destroyed, but it can change. So the question is, how can we prove this? If, what am I talking about? Is it really true? Well, we're looking for the evidence. And very similar to the best evidence of Pangea or geological evolution, it would be fossils. So fossils provide the best evidence that life has changed. Obviously, there are no dinosaurs walking around today. There are reptiles still alive, but we don't have no dinosaurs, we have no pterodactyls, no T-Rex. But based upon the fossil record, we know that they once existed. And so we can backtrack how life may have changed over time using the fossils that are preserved in the rock layers that we call together the fossil record. The other thing we know is that a lot of the things that are around today or never existed if you went back a few hundred or even a few thousand years. A lot of things that existed back then also do not exist today. And so one of the things we know we can look at is this term called extinctions. And an extinction is what we will categorize as any time huge numbers of organisms go extinct at the same time. So it's called a mass extinction, to be more specific. And there are many reasons why mass extinctions have occurred. For the most part, we're looking at environmental changes like continental drift. If you were a dinosaur species and you lived up here, well, in this area it was nice and warm and temperate, but over time this broke apart and became super hot or super wet, and that just may not have been very good for your species survival, so you may have died out. So there's many reasons why it happens, but it is evidence that, hey, things have been changing. So Taking apart evolution simply is a theory that species change over time. What I want you to highlight is I want you to understand is that this is a slow change. Okay, happens over many generations, and we're talking thousands, if not millions of years. Evolution is not a overnight process. Within this change over time, here's another vocabulary word, traits. And the word traits means specific physical characteristics that can be passed down. So height, skin color, eye color, these are things that are a part of our genes or our genealogy. And so traits equals genes. You look the way you look because your parents gave you certain genes. Well, that's passed down to you. And your genes can account for a lot of physical appearances. There are some genes also attached to maybe even the ability to do certain things in terms of intelligence, although that gets to be a bit of a murkier concept. So if you're looking at how these genes are passed down, a guy called Charles Darwin, he wasn't the first one, but he is the most famous one to come up with this theory called natural selection. So if you're looking at this term, what Charles Darwin said, and a short backstory is that Charles Darwin actually was a quote-unquote Christian, and he came up with this theory of natural selection while I was on a journey, and he actually kept it a secret for a very long time. He was very much afraid of the powerful Church of England at that time, of being accused of being a heretic or being a non-Christian, which in those times was a big deal. And he only actually published his book when another scientist came up with almost the same concept as he had, and he decided, hey, if anyone's gonna get famous off this theory, it's gonna be me. So he came up with this thing called natural selection, and what he said is that if you are a member of a species being any individual organism, if you got better stuff than me, you will survive better. And if you survive better, then you will have more offspring. And offspring is another word for babies. So that's my way of saying it. Here's the fancy way of saying it. Members of a species best suited to an environment reproduce at a higher rate than others. And the example here is that you have 4 giraffes, and one of these giraffes has a longer neck than its siblings or cousins or whomever. And because this giraffe is taller, he's able to eat more food because he can reach the higher trees. And because he can reach more food, he grows bigger and stronger than his offspring. And so that trait of being a very, very long neck, he will pass on to his kids, and all of his kids will now have long necks, and they will eat better and get stronger than all the other short-necked giraffes. And eventually, as these guys are starving, these guys are thriving, which means doing really well, and they are making more babies because they're eating better and living longer. And so eventually, all the giraffes in that area have long necks. So the trait of having a long neck is what is passed down. The first person to really say this was a guy called Jean-Baptiste de Lamarck. And he looked at these giraffes and really said, hey, he felt that that's what the process of evolution was. And so when we use the word evolution, we're not talking about this change of monkeys to humans. That's not what evolution is. It's really a series of really small changes over a very long period of time. So here's one of the more famous examples of it, make it a little bigger, is the modern day whale or dolphin, killer whale, however you want to call them. And they believe, based upon fossil evidence, that the dolphins, their ancestors was a tetrapod, a 4-legged animal that lived on land. Well, this guy eventually found out, hey, there's more food in the water and started swimming a lot. And so over the next 10 million years, as this animal spent more and more time in the water and passed off the swimming ability, the traits for swimming was passed on. So this is a 10 million, very long time change. And so the front fins the front legs got shorter and they have a webbing in between. The back leg got pulled up. And this is to keep the body what they call hydrodynamic, which means that it can cut through water fast. Now, that took a 10 million year gap. Over the next 20 million years, so some 30 to 50 million, this guy evolved into the modern day whale with the legs pulled all the way in, with now a flipper and now fins, and the nostril went from being the top of the nose to the top of the head. Over the next 25, 30 million years, we now have a modern day toothed whale, like a killer whale or a dolphin. So what I'm saying here is that evolution is a change over a long period of time. So over 60 million years, give or take, it took for this tetrapod, this four-legged dog-like creature, to become a modern day whale. And so what we're looking at is evolution over a change over a long period of time. So here's your example of the giraffe. Let me go back a quick second here. If you look at here, so what we're looking for, or the theory that this is produced on, is once again looking at the fossils and looking at these intermediary species and trying to show relationships between them. And so if this guy is very closely related to this guy and this guy is related to this guy, it shows that they have some similar ancestry or heritage. And so we're looking at the bones that are preserved in rock, which we call fossils, to prove that this may have actually occurred. So back to the giraffes and how they survive. So natural selection through adaptation. So here's the example. You and I are running from a bear. And Mrs. Smith is definitely faster than all of y'all. I've seen y'all run. All right. So if I run faster than you, so I'm changing it, you're going to die. But if there's a gene in my body that helped me be fast, as I procreate, or as there are more babies from my ancestry or heritage, they're going to have the ability to run faster. Okay, so put this in simple terms. You go to a village. 4 guys goes hunting. One of them is fat and slow. One of them is skinny and weak. The other one is big and strong. The other one is lean and fast. They go hunting. They hear a big roar. They see a lion. They all run from the lion. Well, who gets eaten? Well, it's probably going to be the bigger one and the slower one. Or maybe the big guy, trips another person down. That's what I would do. But either way, whoever died or get eaten by that predator, they're going to lose the ability to have kids because they're dead and they got eaten. And so whatever traits, whatever genes that made them special dies with them. Okay? And so those other 3 guys go out hunting, and that's another one dies. And so these guys go back to the village, and now there's, a lot of women without menfolk. So those guys will now procreate with more women and therefore make more babies, and over time, whichever trait that let them survive would be more common. And that's really why you find that people from similar ethnic backgrounds look similar. Before we had migration and immigrants and people moving around, people pretty much were born somewhere and they died in that same area. We don't have all that movement that we have in present day. And so people from Kenya or certain parts of Africa or certain parts of Europe, whether you were Scandinavian or like a Viking, they had a look, and that look became a trait of that country or that tribe because it was something that helped them survive. That's the summary of natural selection. So You're going to have an ed puzzle to do on Darwin and his early evidence that we'll get into deeper. That will explain how he looked at the turtles and the Galapagos finches. So I won't go deep into that because hopefully you will get that from your ed puzzle. So that's a lesson on natural selection. Hope you paid attention.